So consider this given problem statement. So it states that the product of all positive real values of x satisfying the equation, that is x to the power 16 times log x base 5, and this is cubed, minus 68 times log x base 5, and this is given equal to 5 to the power minus 16. Now in this given equation, first of all let me just note down this given equation. Now to simplify this one, what we can do, so you can observe here log base 5 is mentioned, right? Log base 5. So in order to simplify this one, I will take log base 5 on both the side, right? So for this one, I'll take here, for this expression, I will take log base 5. So in this one, I'll mention here log base 5, and the same thing for the RHS as well, right? Now if I apply the property of logarithm, that is, whenever we have log base 5 and in the argument we are having certain power, so this power expression would be taken here, right? And this can be written as log base 5 x, and in this side we can write negative 16 times log base 5, and then argument is 5. So whenever the base and argument is 5, and given the condition that the quantity remains defined, so in that case we can write there 1. So this entire expression can be written as equal to negative 16. Now you can observe here, there are multiple occurrence of log x base 5. So I'll consider some other variable. So I'll say, let us consider u as log x base 5. The reason for this one is so that we can simplify this equation in a easier manner and effective manner, and that's why we are applying this strategy. So now I'll put this here as it is, and wherever log x base 5 is there, I'll replace that by u. So this is u cube, and this will be u as it is, and here again log x base 5. For this I'll be writing u. Now on resolving this further, so I'll get 16 times u to the power 4 minus 68 times u square, and that is equal to minus 16. Now from this, if I simplify this further, so you can observe clearly that this can be written as 4 times u to the power 4 minus 17 times u square and plus 4, that will be equal to 0. Now there will be 4 distinct roots. Okay, consider. So consider the roots are, let's say, u1, u2 and u3, and the fourth one is u4. So these are the 4 roots, right? So from this one, we can say that my u1 would be log base 5, and here let's say x1. Then similarly for u2, I can write in a similar way that this will be base 5 of log base 5 of x2. Then for u3, I can write again this one as log base 5, and here x3. And similarly for u4 as well. So for u4 as well I can write log base 5, and here x subscript 4, right? So these are the roots. Now I'll take the sum of these roots, that is log base 5 x1 argument, right, plus log base 5 argument x2, then plus log base 5 argument x3, and then plus log base 5 argument x4. Now if I take sum of all these roots, this will be equal to 0, right? So this will be equal to 0. Now here I will apply the property of logarithm further, that is, this further implies that is log base 5 and the product of all this, that is x1 times x2 times x3 times x4, this is equal to 0, right? And from this one we can mention, if I convert this into exponential form, then the product of these 4 values, that is x1 times x2 times x3 times x4, this can be written as 5 to the power 0, and non-zero number to the power 0 is equal to 1, and hence for this problem statement this is equal to 1. So 1 is the answer for this one. So the product of all positive real values of x satisfying this particular equation is nothing but 1. So 1 is the correct answer.